All right, so first I'm going to start off with you guys. It's Miss Everly here. And these are the problems that you were supposed to practice in class. And I'd just like to go through a couple of them because I think some people are still having some issues here. I'm going to go through, let's pick this one, and let's pick something like this one. Okay? All right, so let's start with this one. Yeah, 4 times b is supposed to be less than or equal to 16. What you guys have to get in your minds is that this is the original problem. Okay, what we're trying to figure out is what are the solutions for b that'll make this original inequality true. So if we go ahead and solve this algebraically, we would divide by 4 on both sides, and we end up with this. So now you should always check to see if your solutions actually work, because sometimes they won't, which means you might have forgotten something and the bell didn't go off in your brain and you need to change the inequality. So if I graph my solutions here, just see where they're at. There's 4, and I go 1 up from that, 1 down from that. Use a closed dot because it can equal 4. I can not only see it, but it can be it. It can be it. That's a good one. And then my solutions are supposed to be less than or equal to 4. So they're going to exist over here. So now if I'm checking it, you guys, I check it back in the original. So my check work, if I pick 2 to check, I'm going to take 4 times something and see, is it really less than or equal to 16? So let's pick something from our solutions over here. So let's pick something like, what are some solutions that exist over there? 0 exists over there. So is 4 times 0 less than or equal to 16? Well, yeah, because 0 is less than or equal to 16, so that works. If I pick something else to try, let's say I pick 4 times negative 5. Is that less than or equal to 16? Negative 5 exists way down here on the number line. 4 times negative 5 is negative 20. And is negative 20 less than or equal to 16? Yes. Okay, so these are true solutions. That is going to work. Now let's go ahead and try number 35, and you'll see why I picked that one. So number 35, negative 4 times s is greater than or equal to 64. Here is my original. Okay, that's what I'm going to go back to check it. So to get s alone, I'm going to divide by negative 4. So 64 divided by 4. 4 goes into 6 once. I'm left with 2. 4 goes into 24 6 times. They are different signs, so it's going to be negative. Okay? So at this point, you might think that I did something wrong, but I'm going to keep going. I'm going to graph my solutions. Negative 16. It's a closed dot because it can equal it. 1 up from that, getting closer to 0 is negative 15. Getting farther away from 0, negative 17. And my solutions, it says here, are supposed to be greater. So where are greater solutions? They're over here to the right. So now if I go back to the original and I check to see if I'm good, I'm going to check negative 4 times something that exists over here, and I'm going to see, is that greater than or equal to 64? So let's pick something that exists over here that's easy to plug in, like let's say negative 10. So I'm going to take negative 4 times negative 10. That's 40. Is 40 greater than or equal to 64? No, it did not work. Is this just a fluke? Let's try another one. Negative 4 times, what is another number that exists over here? 1 exists over there. Is that greater than or equal to 64? So negative 4 times 1 is negative 4. Is that greater than or equal to 64? No again. Okay, so we're getting things that are in our solutions that are not working. So there's something that we messed up on. And it was because when I divide by a negative 4 on both sides to solve, there should be a bell going off in my brain saying that when I do that, the inequality is not going to be true, meaning I have to switch my solutions to being less than negative 16. So I'm going to redraw this out, I'm going to have my line, and I'm going to, it's still going to be at 16, negative 16, but it's, the solution should be over here. Okay, and now I'm going to actually check and make sure that works. So I'm going to plug in numbers and see if we're good. Negative 4 times something that is this over here. Let's try like negative 20. Is that greater than or equal to 64? Yes, because 80 is greater than 64. If I try another one, like negative 4 times negative 30, is that going to be greater than or equal to 64? Well, yes, because that's 120, which is greater than 64. Okay, so I wanted to make sure you could see the difference between those two. And then one other problem that I wanted to get to was a word problem. So you guys tried a word problem yesterday on the video, and now you're going to try another. If you feel like you could do this on your own, go ahead and try. Pause the video, see what you could do. Otherwise, just keep going with me. You could read it through with me if you want. So at first, I'm telling you that Summer's family, a family, they're going on a family road trip. So look at this picture I brought. Look at this family. Look at that family. The Griswolds. They are headed out. They are happy about it. You're like, yes, I am out of here. I'm going on a family road trip. So this is the Summers family. And they've completed, man, they've gone far. They've gone 35 miles so far, okay, on their road trip. The family wants to drive at least 245 miles by the end of the day. They want to drive at least 245 miles. Mr. Summers plans to travel at a speed of 60 miles per hour for the rest of the trip. Good for him. Hopefully the speed limit is 60. So it gives you an inequality to use even. The inequality is 60h. What do you think that means? 60 per hour plus 35. What does that mean? The 35 miles they already drove. Needs to be greater than or equal to 245. Why is that? Because it says they're going to need to drive at least 245 miles. So it represents the number of hours each the family plans to drive. Solve the inequality and graph the solution set on the number line. Show your work, then interpret the meaning of the solution. So I have 60h plus 35 is greater than or equal to 245. We're going to go ahead and solve. So how do we solve that thing? Well, we're going to need to subtract 35 first. Subtract 35, and when you do that, I'm going to be left with 210. And that's supposed to be less than or equal to 60h. So 60h should be greater than or equal to 210. To get rid of the 60, I'm going to divide. And the number of hours, 210 divided by 60, will be the same thing as just 21 divided by 6. So this is 3 and 3/6, which is really just 3.5. So the number of hours. So now here's my solution. Does it say I need to graph it? Graph the solution set on the number line. Okay, so on the number line, what's going to go in the middle? 3.5. And then it's up to you, kind of, we've been working with whole numbers, but I'm just going to go ahead and go up to 4 and go down to 3. It's up to you what kind of increments you want, but you need to keep them the same. I chose to go up by half and down by half. And then it can equal 3.5. And then my solutions need to be greater than or equal to. So there's where my solutions exist. Now, can you interpret this solution? How would you write this out in words? Well, I'd probably say the Summers family. Is that the name of this family? Yep. The Summers family. So the Summers family needs to drive 3.5 hours or more in order to drive at least what was that number? At least 245 miles by the end of the day. End of the day. Okay, that is all over the place, and I even drew over the Summers family. So I will see you in class for some more practice.